Assalamu alaikum students, how are you all? Hope so all of you are fine and enjoying your vacations. Students, today we are going to take start from exercise number 1.6, and we have done exercises up to 1.5. And what are the topics? I have told you in the previous lecture, you must do practice on daily basis, then you will be able to cover the exercise 1.6. In the previous exercises, students, we have done the topics how to add the matrices, how to subtract the matrices. We have discussed different types of matrices, and then we have discussed how to take determinant, adjoint, and then inverses of the matrices. Students, you must know that division is not possible in the matrices. So whenever we have to take the division process, so we will take inverse. We will not divide the matrices, we will take the inverse. And we have also discussed how to find the inverse of a matrix in our previous lecture. And in the previous in the inverse, what is there? Determinant and adjoint. Okay student, now the next topic is simultaneous linear equations. Students, you are well familiar with the linear equations. What are the linear equations? In linear equation is the equation in which the exponent of the variable is 1, like x plus 2 is equals to 0. You can see the variable is having exponent 1, so this is called as the linear equation. If the exponent is other than 1, suppose 2, then it will not be a linear equation. Similarly, if I am having another example like this. Now friends, this is also a linear equation involving two variables. This is linear equation involving one variable. This is linear equation involving two variables, as both the variables are having the exponent 1. Now students, what is simultaneous linear equation? Basically, simultaneous linear equations are the group of the linear equations. If you are having two or more than two equations and variables are involved in it, a different number of variables are involved in it, then you can say these are simultaneous linear equation. We are going to discuss two simultaneous linear equation. Friends, you must know that if, for example, we are having two variables in a linear equation, so for finding the value of the variables, we must have two linear equations. This is called as a simultaneous linear equation, right? Now you can see in both the equations you are having only two variables. So finding the values of the two variables, we must have two linear equations. If we are having three variables, then we must have three linear equations to find the values of these variables. Okay. Now students, this is called as the simultaneous linear equation. Now students, we are going to study how to solve these linear equations, this simultaneous linear equations. We are going to discuss only two methods. Number one method is matrix invariant method, and number two method is Cramer's rule. We will just discuss these two methods. There are more methods to solve linear equations, but we are going to discuss only these two in your exercise 1.6. Students, remember one point, that whatever you are adopting the method, the answer of your question will be same. Where I am going to solve question number 1, part number 1, with both the methods, matrix invariant and Cramer's, and you will see with both methods you are getting the same answer. Another point, students, you have to keep in mind that whenever you will going to solve the linear equations, if the determinant is equals to 0, then you will just write the statement that the inverse is not possible, therefore you cannot solve the linear equations. Okay, because in linear equation, firstly you have to find the inverse, then you will solve further question. So if inverse is not possible, obviously you will stop the question just by writing the statement that inverse is not possible. And when inverse is not possible, when determinant is equals to 0, means this is a singular matrix. If it is a singular matrix, then inverse is not possible. Okay, now we are going to start our first method. Okay students, now this is the part number 1 of question number 1, and firstly I am going to solve it with the matrix invariant method. Students, in both the method, first of all you have to convert these linear equations into the matrix form. And how you will convert it into the matrix form? First matrix is always of the coefficients And what are the coefficients? Coefficients are the values which are multiplied with the variable. These are the multiplying factors of the variable. Like this 2 is coefficient of this x, this is -2, this is 3 and 2. We will write these coefficients in matrix form. 2, then -2, then 3 and 2. 3 and 2. Okay. Next will be the matrix of variables. Variables are x and y. So we will write like this. X, y is equals to matrix of constants. 4, 6. Now the matrix invariant method is going to be started. This step is will be included in both the methods, in Cramer's or in matrix invariant as well. Okay, first matrix is always called as matrix A. This matrix is called as X and is equal to this matrix is called as B. Now we have to find the values of the variable. So value of the variable is the X matrix is having the variable. So we have to find this X matrix. X will be equals to this A is multiplying here. On the other side it will be inverse of A, because division is not possible in matrices. In matrices we have to take the inverse. So now to find the values of these variables, we have to find the inverse and then we will multiply it with B. This is matrix B. Okay. To finding the inverse, it is the same procedure as you have done in exercise 1.5 and you have also done multiplication in 1.4. Just simple, you have to learn the formula for finding the values of the variable involved in this. Simple, we will find A inverse, and you know what is the formula of A inverse? It is 1 by determinant of A into adjoint of A. With the same method we will find the inverse. First we will find the determinant, and what will be the determinant? 2 minus 2, 3, 2, and its determinant will be product of diagonal entries, this is 4, minus product of non-diagonal, this is -6, and answer will be 4 plus 6, 10. And next is the adjoint. For adjoint, you have to change the places of diagonal entries. These are same, so you will not feel any change. And signs of the non-diagonal entries. This will be 2 and this will be -3. Now we will put these values in the formula. A inverse is equals to 1 by 10 into adjoint of A. 2, 2, -3 and 2. Okay. Now, students, this is just A inverse. For finding X, we have to multiply this A inverse with B. So, X is equals to A inverse B. A inverse is 1 by 10 into adjoint 2, 2, -3 and 2 into B. What is B? B is 4 and 6. Now we will multiply these 1 by 10, and when it will be multiplied, the process of multiplication. 2 into 4 is 8 plus 2 into 6 is 12. 2 into 4 is 8 plus 2 into 6 is 12. -3 into 4 is -12 plus 2 into 6 is 12. So now this is 20 and -12, it is 12. -12 plus 12 is 0. Okay, now this 1 by 10 will be multiplied by both values. 0 multiplied by 1 by 10, and answer will be, this will be 0, answer will be 2, 0. Basically, this is the matrix X, so these are the values of X and Y. And what will be the value of X? X is 2 and Y is equals to 0. This is the method of matrix invariant. Firstly, you have to find the inverse, then you will multiply it with B, then you will get the values of X and Y. Now students, I am going to solve the same question with the Cramer's rule as we have done it with the matrix invariant. Now you will see with the both method the answer will be same. Whatever you are adopting the method, the answer of the question should be same. So I am going to solve it with Cramer's rule. And I have told you the first step of both the method is to convert the equations in the matrix form. So what will be the matrix form? Same as we have done before. first matrix of coefficients, then variables is equal to matrix of constants. Okay students, now in Cramer's rule, first of all you must know the formulas. It is a direct method. For example, for the variable x you are having the formula determinant of ax divided by determinant of a, and for y this is the formula determinant of ay is equal to determinant of a. Now students, if we know the values of determinant of ax and determinant of a, we can find the value of x. So now we will find ax, a and ay. If we will get all these values, just we have to put the values in this formula. So what is a? You know a is this matrix, as I had told you in the previous question. This is a. And what will be its determinant? Yes, it will be product of diagonal entries minus product of non-diagonal. 2 into 2 is 4 minus 3 into minus 2 is minus 6, and determinant will be 4 plus 6, 10. Next is ax. We have to find ax. Okay student, now in ax, as x is the first variable, so we will replace this first column of matrix A, 2 and 3. Instead of this first column, we will write this matrix. Okay, this is 4, 6, and second column will be written as it is. Okay, in first column we will write B matrix, and second column will be as it is in ax. Now we will find its determinant. Determinant will be, you know, product of diagonal entries 8 minus and product of non-diagonal entries. It will be 8 minus minus plus 12, 20. Now ay is there. How we will find ay? First we will find ay. For ay students, you have to replace the second column with matrix B. First will be written as it is, and for the second you will write the matrix B. Okay, now we will find its determinant. 2, 3, 4, 6. And what will be its determinant? Yes, product of diagonal, that is 12, minus product of non-diagonal, that is again 12, and answer is 0. Now we are having all the values, determinant of a, determinant of ax and determinant of ay. We will just put it in the formula. X is equal to determinant of ax is 20 and determinant of a is 10, 20 by 10, x is equals to 2. And we were having the same value in the previous question. And now we will put the values of this. Ay is 0 and determinant of a is 10. So y is equals to 0. Now you can see in both the methods we are having the same answer. Okay students, now you have to do a lot of practice of these questions. Question number 1. In question number 1, I have done just part number 1 with both methods. You have to do the rest of all the parts with both methods. Then you will be able to solve any questions. Okay. Wish you best of luck. Thank you so much. Allah Hafiz.